If you think the universe started with a giant explosion, maybe it's time to rethink. Scientists are questioning whether the Big Bang was really the beginning of everything, and what they've discovered might turn everything we know upside down. The story we know about the beginning of the universe starts with an infinitely small and dense point that suddenly expanded, the famous Big Bang. But what if I told you this theory is far from the final explanation? In fact, new discoveries are suggesting something completely different, and the Big Bang might not have been the true beginning of everything. For decades, we believed the universe began with an explosion. All matter and energy condensed into a single point, and then, boom, the creation of space, time, and everything else. But new theories are challenging this simple view. Scientists have been asking, did the universe really start from a single point, or could there be something beyond that? It all began with Einstein's general theory of relativity in the 1910s. His equations suggested an expanding universe, and if you rewind this expansion, you'd end up with all of space compressed into an infinitely dense point, a singularity, which is believed to have happened at time t=0. The idea seemed to fit, and thus, the story of the Big Bang was born. But like any great mystery, this concept raised new questions. Scientists like Alexander Friedman and Georges Lemaitre began exploring this idea and came to intriguing conclusions. But they made one big assumption, that the universe is perfectly smooth and homogeneous in all directions. But it's not. Our existence proves this, as we are surrounded by galaxies, stars, and planets, a universe with small imperfections. This irregularity could actually change our entire understanding of the beginning. It became necessary to add a new concept, cosmic inflation. This theory suggests that right after the Big Bang, there was an extremely rapid exponential expansion that smoothed out any initial bumps. But instead of solving the issue, this brought even more complications. Eternal inflation. What if the universe has no beginning? If cosmic inflation can happen indefinitely, it means there's no need for an absolute beginning. Imagine bubbles emerging in a vast ocean, each bubble being a universe like ours. The expansion of one of these bubbles doesn't need a fixed starting point. It could have existed forever, expanding indefinitely in the past and the future. Sounds a bit surreal, right? Singularities and black holes, a clue on the horizon. Now, to complicate our journey further, comes the concept of singularities. When we talk about black holes, for instance, we know they contain a point at the center where the laws of physics, as we know them, completely break down, a singularity. But there's a fundamental difference between the central singularity and the black hole's event horizon. At the horizon, it seems like time blows up, but it doesn't mean that space-time ends there. In fact, a simple coordinate change can reveal what lies beyond. This raises an intriguing question. Is the Big Bang singularity truly a physical end, or just a coordinate illusion, like the event horizon? In other words, could there be something before the beginning of the universe? Here's where we step into unknown territory. Scientists have been working with a concept called geodesic incompleteness. Simply put, a geodesic is the shortest path between two points in space-time. But if these lines hit a dead end where they can't be traced further, this suggests the literal end of space-time, like the universe's edge of the map. This idea was explored by Roger Penrose in his famous black hole singularity theorem. And it has also been used to explore the universe's beginning. Geodesic incompleteness suggests that all paths in the universe end up converging to a single point, which is a strong indication of a beginning. So, did the universe really start with the Big Bang? The evidence points to a singular point in the past, but new theories lead us to believe there might be more. For example, the 2003 Borde-Guth-Vilenkin theory suggests that any universe that has consistently expanded over time cannot have an infinite past expansion. This would indicate a boundary, a kind of beginning. On the other hand, recent research indicates that if our universe is just a part of a larger space, like de Sitter space, it could be possible that the beginning is just an illusion of our coordinates, like the black hole's event horizon. However, for this to happen, the density fluctuations at the start would have to be minimal, which contradicts evidence that our universe was a rather lively place at the beginning. If you enjoyed this video, subscribe to the channel for more cosmic content.